problem. So it asks, what operation is used to find the missing factor? So quick reminder, factors are two numbers that you multiply in order to get a product or an end result. So I'm missing a factor here. That's what this question mark is for. So if I want to find it, what mathematical operation would I use to find that missing factor?
You would divide by 23.
Yeah, you would divide by 23, so I'd use division. So in order to find missing factors, we divide. So let's do a little old school division here. 23, okay, so y'all remember how to do this? How to old school long divide? So I need 23 to go into 97. How many times will 23 go into 97? 4. So I put a 4 right here, and then I multiply 4 times 23, and that would give me 92. And then I subtract, right? 7 minus 2 is 5. 9 minus 9 is 0. I can bring down the next number, so I bring down the 7. So now how many times will 2 go into 57? Or 23. How many times will 23 go into 57? Twice. So then you multiply. 2 times 23 is 46. Now we subtract. That leaves me 11. And bring down the 5. So how many times will 23 go into 115? 5 times. 5 times 23 is 115. So there's no remainder here. So the missing factor is 425. Everybody remembers long division? Okay, well, good. Because now we're going to long divide polynomials. So to find missing factors in a polynomial problem, we're going to do the exact same thing. It's called polynomial long division because we're long dividing polynomials. So in this case, they gave me this cubic function, x cubed plus 5x squared minus 5x minus 9. And I know one of the factors, x plus 1. I need the other factor. So I'm going to divide in order to find it. So my polynomial goes inside of my division bar. That makes it the dividend. The x plus 1, or the factor that I know, goes on the outside. And we're going to long divide. It is the exact same process that you use when we long divide regular numbers. So the first thing I'm going to do is I'm kind of going to ignore this plus 1, just like, and I'm going to ignore everything but the x cubed. Just like up here we ignored the extra 7 and 5, and we just did 23 into 97. I'm going to do x into x cubed. What would I have to multiply x by in order to get x cubed? X squared. So that's what's going to go right here. Now I'm going to do exactly what we did when we long divided. You multiply. X squared times x would be x cubed. X squared times 1 is positive x squared. Now, up here what we did was subtract. But when we're dealing with polynomials, it's easier to think of it as adding the opposite. So I'm going to take everything that I just came up with, x cubed plus x squared. I'm going to make it opposite of what it is now. So I'm going to make it negative x cubed minus x squared. And then I can add straight down. So x cubed plus negative x cubed, that's gone. 5x squared plus negative x squared would be 4x squared. And I'm going to bring down the next piece in line. So negative 5x. All right, everybody all okay? Now we just keep doing the same process until we finish. So I ignore everything but the first term of each. So I figure out, what do I multiply x by in order to get 4x squared? 4x. Positive 4x. So I'm going to put positive 4x. Now I'm going to multiply. 4x times x would give me 4x squared. 4x times 1 is positive 4x. So now I'm going to change the signs on everything underneath because I'm going to make it into its opposite. So I'm going to make it negative 4x and negative 4x squared and negative 4x. That way I can add straight down. When I add straight down, my negative 4x squareds cancel. Negative 5x and negative 4x is negative 9x. And I bring down my minus 9. And you do the whole thing over again. I ignore everything but the first term of each.
Wait, where did that minus 9? Oh, because that term's negative.
Yep.
Okay.
All right, so now, what would I have to multiply x by in order to get minus negative 9x? Negative 9. So I put a negative 9 up here. Then you multiply. Negative 9 times x is negative 9x. Negative 9 times 1 is negative 9. Change the signs on everything underneath because you're making it opposite. And add straight down. And you get 0. We okay? We'll do a couple more together before I do them by yourself. All right, so looking down here at number 1. This says by multiplying the factors, so they've got 2 factors here. They distributed them out or FOILed them out and got 2x squared plus x minus 15. So they just want us to show using division that these 2 things are in fact factors. So they've put the polynomial underneath. I've got 2x minus 5 out here as my divisor. I ignore everything but the first term. What would I have to multiply 2x by in order to get 2x squared? X. Since it's just an x, you line it up over the term that it is like. So x is like, it's a linear piece, so I line it up over the linear piece. Multiply. X times 2x is 2x squared. X times negative 5 is negative 5x. Change the signs on everything underneath to make them their opposite. And add straight down. My 2x squareds cancel. X plus 5x is 6x. Bring down the negative 15. Alright. I ignore everything but the first term. What would I have to multiply 2x by in order to get 6x?
3.
Positive 3. So I put plus 3. Multiply through and you get 6x minus 15. Change the signs on everything underneath and add straight down. You get 0. Everybody good? All right, do number 2 real quick by yourself. You should have gotten 2x minus 5, which you already knew because I told you what it was, but just check to see if you did it correctly. Is everybody good so far? Any questions? Okay. All right, so now the problems are getting just a little bit longer. So they've given me the polynomial. They went ahead and put it under the division bar, so that's your dividend, and your divisor is x plus 5. So we're just doing the same process. Ignore everything but the first term. And what would I have to multiply x by in order to get 2x cubed? 2x squared. And so I'm going to put the 2x squared above the other quadratic piece. That's just kind of how you do it. Get them lined up. And so now I'm going to multiply 2x squared times x will be 2x cubed. 2x squared times 5 will be positive 10x squared. Change the signs on everything underneath to make it its opposite and add straight down. And you keep going. So what would I multiply x by in order to get 7x squared? 7x. Multiply, that gives you 7x squared plus 35x. Change the signs on everything underneath and add straight down. What would you multiply multiply x by in order to get negative 4x. Negative 4. Change the signs on everything, add straight down. So you got 2x squared plus 7x minus 4 is your missing factor. Everybody feel okay so far? Okay, think you can do 4, 5, and 6 by yourself? Go. On 4, I got 2x cubed plus 3x squared minus 5x plus 4. On 5, I got x cubed minus 6x squared plus 8x minus 5. And on 6, they end up zeroing out before, and then so you get x squared plus 4. You don't have a linear piece on this one. It's just x squared plus 4. Are we all good? Is everybody okay? Okay. Awesome. That's polynomial long division. Okay. So now we get to go back and remember last week we did synthetic substitution. So now we're going to use synthetic division instead of, we're not using it to substitute, we're using it to divide. So they ask us to consider this function x cubed plus 7x minus 50x plus 24. And they want us to see if we can figure out which one of those would give a remainder of 0. So which one do you think? It just says circle one. Let's just pick one. Which one do you think that would give us a solution of 0?
X equals 5.
You think 5?
Sure.
Okay, so let's put 5 in the box and let's try it. So I'm going to bring the 1 down. 5 times 1 is 5. 7 plus 5 is 12. 5 times 12 is 60. 10, 50. Okay, 5 didn't work because I have a remainder of 74. So let's try another one. So I'm going to put my coefficients back. 1, 7, negative 50, and 24. What should we try now?
X minus x equals
3? Okay, so I'm going to put 3 in the box. Drop the 1. 3 times 1 is 3. 7 plus 3 is 10. 30. Of course we chose the wrong one. Here. Not that one either. It better be 4.
It's a trick question.
What if it's not? I think it is though. Aha. All right, this one gives a remainder of 0. So based off of that, that means that x equals 4 is a remainder of 0, which means it is a 0 or a solution, which means which factor would be a factor? X minus 4. Then it says use the factor from part B, so this factor, to find the other factor using polynomial long division. Okay, so I now know that x minus 4 is a factor. So I'm going to set it up with my polynomial underneath. So x cubed plus 7x squared minus 50x plus 24. And now I'm going to long divide like we were just doing. So what would I multiply x by to get x cubed?
X squared.
X squared. Multiply. Change all the signs. Add straight down. So I get x squared plus 11x minus 6. We're all good? Okay. I want you to notice something before we go to the next one. Look at what I got when I long divided, and look at what I got when I synthetically divided. It's the same. Synthetic division will get you the same result as long division. This just doesn't have any x's on it, but I could go back and put the x's on it. My coefficients here would be 1, positive 11, and negative 6, and you got 1, positive 11, and negative 6. So synthetic division and long division are essentially, I mean, they're both divisions, the same thing. So on number 8, they want us to do the same thing. Consider the factor, consider this function. Which one of these do you think is a factor? And there may be more than one. Negative 2? Alright, so 2. Thank you for finding the right one. So, that means if negative 2 is the factor, is the 0, then x plus 2 is the factor. So, we're going to long divide. So, x plus 2 is going outside. My original polynomial is going inside. In order to get 2x cubed, I would multiply x by 2x squared. So I got 2x squared minus 3x plus 4, which is exactly what I got over here. It should be, the coefficients of the synthetic division and the coefficients of long division should be the same. All right. Is everybody good? Okay, so with that said, we can use synthetic division to find our other factors. As long as we know one of them, we can find the others using synthetic division. So we will, Valerie's at 15, right?
Yeah.
We'll start right here tomorrow, so just put this up